Welcome to a new test and teardown video. This is something completely different. It is really big and special, this unit. I think I figured out what this one is. Spectra. So that is a wavelength spectral analyzer. And it is from EEL. So I believe that means Evans Electroselenium Ltd. from England. So it's probably quite old. Very special design. So this is of course power on off, but look at that. What are we doing here? This has something to do with some calibration. Set 0. And then there's a mechanical wavelength. Look at that. So the readout go from 400 to 700 nanometers. And when I dial this, something moves in here. There's probably some light going in or out here, and there's probably a light source or a detector or some stuff here. I don't know. Got some optics. And this will be the sample tray. Some special glasses. You can take these up and put in some liquids or whatever you want to sample. So you stick this down here, and then it can move left or right, and then you pull this, tickety tickety tack, and then you pull your samples back and forward, and we got those click here at this rod. So that means it's going to hold the sample at the correct positions, so the 4 positions, so you know where you are when you have the lid closed, and then you pull in and out. Haven't yet figured out what is going to happen on this. Is probably also maybe an intensity readout of the different wavelength you manually tune here. I believe there is something like a meter in here that moves depending on the intensity, because there is a galvanometer in here. So this is set for infinity, and there is a clamp, probably a transport clamp on the left side here. And I think that maybe this is what you do. You crank this up in the infinity, so that means the calibration. You have your probably an open sample, and this is of course your calibration, and then you have whatever you want to sample, right? So in the first one, then you adjust here until your readout is on the infinity sample, and then you will see different levels at the different wavelengths probably. So that's most likely how it works. We got some screws, 2 screws each side. So I think I will be able to lift up the top. It looks like nothing is connected other than the... Okay, this part, we got some wires that's probably coming, or it's probably staying down there. Oh yeah, look at that cool detail. I cleaned this up. It was full of all sorts of gross chemicals, including the sample tray, and this entire area here was full of super gross sticky stuff. I don't know what kind of... Is it full of DNA or something even worse? See, if you drop some chemicals, it's most likely going to follow down here and drop down the holes at the bottom. So you can just clean up your table and then you're going to be fine again. But of course this was full of sticky funny stuff. So I'll put on a mains connector and we'll see what happens when I power this up. So I dimmed the light a little bit because we're going to do a power on test. And that is mains applied. Ooh, we got light. Oh, how cool is that? 14 watts. Oh, look at that. We got some kind of a sexy color down there. What if I... Oh, look at that. If when I crank the... Now that is something. I am in love. Ooh. So that was 700. Oh, let's try that. 650. 600. 550. 500. 400. Oh yeah, this is 475. 450. 425. And then all the way to 400. I really love it. Aha, so that is how this thing works. I think there's a bulb missing because we don't see anything up here. Yeah. But anyway, this is what I will do. I'll try and take off the lid and see if there's a missing bulb. So now we're inside. So this is aluminium. This is casted aluminium. But look at the way that they made the casting. And that hole. Wow, that is really weirdo. But anyway. So this is the inside this big case. See, with my hand here, it's really big. But the interesting stuff is this. And it actually works. What I figured out is there is only one light source. So it's in here. And then there's this moving filter. So see, when I change, when I dial here, I change the color here. So there will be some sort of a filter, a moving filter in here. I think we can open this and have a look. So the light source, there's also some sort of optics that beam up the light in a thin line. So that thin line goes inside this unit. So there's a meter, a galvanometer. So I hit the release, so now it's free. I don't know if you can see this. Let's see if we can. And then if I put in the paper here, so I block the sensor. Can you see there's a little mirror, a tiny little mirror in there that moves? And then there's another line that is now moving, right? Isn't that just cute? This kind of readout. Now I block the light completely, and then I can adjust the set 0, see? A little bit. And then of course I can hit this dial and then crank it down to the infinity symbol. But there. Here you go. If I block down here, it's probably... No, yeah, okay. It's not so easy to see. Tiny little mirror up there. So that will be the meter wires. It goes down to the base, or it's probably just connected directly to the sensor. So this is just probably a wideband detector or something. Oh, look what that is. That is a photo. Yeah. This is a sensor that just directly convert light to voltage. Here you can see the different colors. Wow. I really, really love this. How can they make all those different colors just by a filter? And then also got a little light bulb in here probably. Yep, it is down there. Let's have a look in here. Oh, that is a... Okay, I have to turn off the light bulb because that is really, really bright. Oh yeah, as you see, it's actually a special light bulb. The way that the filament is made like that, so it can actually make this nice line for the indicator. We've got some optics here, and you can't really adjust anything. So that's just the way. Maybe there's a focus here. No, that's just the that's just the line you create. Yeah. What is inside the base? Oh, here we got different colors for the different test samples. Now it's easier to see. And if I pull this, it's just gonna fall off. I think it's because this one is kind of stuck. Yeah, it's definitely completely stuck. So how do I fix that? Whew, that was tough. Okay, this thing can move, but you need like 100 kilos to move it. Oh no! So it's just completely stuck in here. In both of these, I guess. So I need to figure out if there's a screw on the bottom that creates the pressure to this stick, because I want this to be able to move. There's a reason why this one was pulled off. Okay, let's look inside the base. So now we are in the bottom parts of this fantastic unit. Oh yeah, we got even a nice little label here on the back. And the mains fuse. This screw is probably for angle adjustments of the light reflection unit, so we can make this line appear exactly where it's supposed to be on the readout screen. So this is, I believe this transformer is only used to drive the bulb. I don't exactly know what this capacitor is used for. Looks like it is on the coupled, connected directly to the, yeah, just two windings of the transformer. Really? Why do you do that? Oh, we got some, let's have a look in here. Input, output 6 volts RMS. That's all it does. So super low voltage. Probably a connector or something in here. No, I don't know. So that will be, there's probably a little ball in there and a spring. So this is probably what I need to loosen so I can adjust this steel rod so it can move back and forward. What I found is this zero knob. It moves only one rotation. And look at the way the gearing here works. So it only moves the pot very, very little. But it seems like all I have to do is just go to the end and then use violence. See, now I can have another go somewhere else. And then get back again. So that is a funny way to make a multi-turn, and then the normal working range can be moved by simply just using more force. So that was pretty funny. And here's the bulb. It's a little bit funny. The bulb is not in the middle of that one, but the entire scale lights up pretty good. Oh, we got some text here. B60, B whatever it is. 860. Probably month and then year, right? Yeah, this thing could definitely be from 1960. You could also be lucky to find dates or years on capacitors. Not on that one. Yeah, but that is all there is about this nice instrument. It's really made with, you know, good quality components, and everything is big and thick, and I mean, this is super good quality. I wanted to see exactly what is going on here, so I took away this part. This is the color filter, and I believe this unit should be able to... No, this is kind of stuck. I did of course leave two tiny little marks on each side here, so I can put this back at the exact correct spot. And then I put this for 400, so I know exactly where to put it. Isn't this just nice? So this is the color filter. It is a little bit dirty, and some kind of chemicals went in there, I guess. Whoa, it is really, really dirty. But it still works. It's also very, very heavy. So I guess, yeah, oh yeah, it's very, very thick, this kind of glass. Maybe it consists of many layers of funny things. Ooh, there's a funny line here. Okay, this is just light. How the heck is this made? I don't dare to open it here, and it's probably going to fall to pieces. There's many layers of funny stuff in this one, and it will be real stupid to break it, because now the whole thing really works, and it is super, super cool and funny, this unit. So I definitely want to put it back and have it working. Oh, by the way, I also fixed this. Look, ta-da! It was this one that was moved. So I just adjusted the knot on the back, and then, see, ta-da! And then we got different colors. A little bit funny. And then there's a clickety-click over to the right. So all that mechanics works perfectly fine. So this is indeed a photo cell made in England. How cute is that? Can't really sit anywhere wrong. It can only be mounted the right way, so I do dare to poke a little bit with that, because I don't want to ruin the calibration, because it works. And here we go with the... I actually got some high precision filters. I know exactly what kind of wavelengths they peak, because I do also play with optics and stuff like that now and then, and my plan is to test those and see how it all peaks up, if it's exactly at the right wavelength. Otherwise, I think there's a possibility to fine-tune here by moving the scale somehow, right? How do you calibrate this thing? So this is how the mounting works for this front plate. So it's not going to press too much or too little. You don't want any false light to go in here or anything like that. So this unit here is, as you can see here, see, it can move a little bit, and if I push too much here, it will go out in the other side. If I push in the middle, see? So to get the right tension on this plate, this is actually a spring device. So when you screw this in here, it's going to push on that plate with exactly the right force. See, this is a spring thing. They thought about everything. Small little cool details. So after a little bit of cleanup, it is of course working. So now it is on 700 nanometers, and I get this readout. So let's crank the switch to the calibration. See, I think I did this real nice. There's actually this tiny little line there that is also created by the optics. That is a little bit amazing. I didn't see where that is coming from, so there's probably a thin line in the, I don't know, where is that actually? So let's go in the readout again and see what happens. So this is, I don't have anything in it at the moment. So what we're reading now is the response of the unit itself, right? It's still a little bit dim in here because I don't want any false light to trigger anything. Let's see if I can show you guys this. So this is 700, and then see what happens. Let's go down. So at 675, I overdrive because of sensitivity. So that means this is my maximum sensitivity range from 675. And see, it drops quite a lot of sensitivity from 700. And if I even go more than 700, see. And then all the way down. Yeah, look again. To 425. So that is my response. I really love this, the way that it is displaying this. Look at that. Isn't that just cool? This is probably going to be a little bit difficult to show you guys. So what I am testing with here is a professional filter. Just put it into a little piece of cardboard like this, so that no false light will be able to pass through this one. And this filter is a 530 peak, and it's 50 nanometers wide. All we have to do is mount it the right way. See, there's even a little arrow. So this one is the input. So if I put this here and aim for maximum signal, but what I want to find the peak. So I'm just moving it a little bit away from the maximum because I can't see anything if it's outside of the scale, right? So then I can dial around here. And then I can find the B. Look at that. I mean, that is 530. It is that accurate. This thing is from 1960 something, right? And it is spot on. And the resolution is just insane, and sensitivity is super, super nice. I'm actually quite happy about this one. And it's really, really, well, it's a very special design. I must say, I don't know if it's beautiful or if it's ugly. I will let you decide what you think. Please tell me in the comment if you find this beautiful or if you find it ugly. That could be interesting. Let's vote. Thank you for watching anyway.